everybody. What's happening? You might give me a 5 for 5, and we will. Hey, Miss Dragon, good to see ya. Good to see ya. Monica C gets the cookie for being the first one here. Heck yeah, baby. Heck yeah. Hey, Michael. What's happening? Hey, Brinklin. Good to see you. Stephanie, what's happening? Guys, can you guys please share it out? I would really appreciate that. Mods, I really do truly appreciate you. I really honestly do. No kidding. I can't do this without you guys, 100%. But yeah. So we've had some stuff going on, and yeah, so we will just take a look at that. Yeah. Miss Dragon, if you don't want that, let me know, and I'll, I can go in there and fix that. You got a wrench if you wanted it. So anyway, hey, what's up, 70? Okay, so what are we going to talk about today? Well, we've had some stuff going on. Nothing really like too extreme, but we do have some stuff to talk about. We've had some more eruptions on the sun. We've got a coronal hole that I spoke about a little bit yesterday. It's a sizable one. It's thin. I don't want to say it's thin. It's more vertical than it is horizontal. And it is crossing over the equatorial line, which is one of those signs that points us towards the ongoing pole flip for the sun, magnetic polarity flip. Okay, that is the sun cycle. It happens roughly every 11 years, and yeah, so that's what happens with that. Just keep in mind, guys, when that happens, the polarity of the sunspots is either negative positive or positive negative, right? So when that pole flip happens, guess what? It gets reversed in each hemisphere of the sun. Now, that's not a big deal. We just have to pay attention to it, right? Everything that I'm talking about here, almost all the time, deals with magnetics. Magnetics, gravity, orbital mechanics, all those kinds of things that I don't usually go try to use those words because those kinds of words tend to scare people that don't understand space weather or just don't understand science at any kind of level at all. And my goal here on this channel is to give people, enough information and put it out there in a way that isn't so daunting to try to understand. What's the worst that can happen if you don't know something? You just ask the question. It's really that simple. You can't screw nothing up. There ain't nothing here to screw up. You guys can go clicking on all these things that I click on, and I've shown you guys how to do that. And I'm going to do that real quick right now anyway and show you. So if you guys go here to NOAA Space Weather Prediction Center, you can simply Google it. Use a link. One of my mods could probably put it in the chat if they wanted to for me. That would be awesome. Just put the link to this page. Copy and paste it, or just copy and paste the URL and put it in the chat if you would, guys. If not, no big deal. But you guys can just type that in. And if you scroll down, once you go there, everything I show you guys pretty much is right underneath here on the bottom of this page. All these links. Okay, there are a few that I show you guys that aren't on this particular page. But if you're new to all this, this is a great place to start. Because you can come over here to where it says Space Weather Enthusiasts, right? Under Dashboards. What's that do? When you click on that, it takes you to the same page right here that we're looking at right now. Because you can click around it. What they've done is they put different dashboards and they specified them. Okay, this is the Aurora dashboard, so anything dealing with Aurora that is important, that what they would think people need to see, is right here. Okay, so, and likewise, like I said, if we just want an overall space weather enthusiast kind of view going on here, they're right back to that. So, I mean, all these different dashboards are there, and you can't screw it up. Also, if you have questions on what things are, this is another great way to learn what to look at when we're talking about certain specific subjects. Like, again, I'll go to the Aurora one. Right here. Aurora dashboard. When and where can you see northern and southern lights tells you right here. You just read it, right? You can go deeper in once you start understanding dive deeper into the science of aurora. Tips on viewing aurora. I get that question so many times. Thanks, Dragon. Thanks, Stephanie. Appreciate you. Hey, Daryl, what's up? What causes aurora? Where can I go out and look at these things? Where is it going to be? Right? So if you guys have this stuff right here in front of you, right? And there's also a great app that you guys don't. I've been mentioning it quite a bit lately. It's the Carrington app, and it simply is a lot of these models I show you along with other ones. Okay, you can get the app. You go over there and you click around, and it's right there at your, on your phone. You don't have to really go searching for anything. It's all there. And Todd, the guy that runs the app, is an awesome dude. Again, he's giving me a free membership so I can use it and try it, and I've been giving him feedback and stuff on it, and he listens. He really wants to make the app the best he can do, the best it can be. And in my opinion, he's doing an awesome job over there. So, but anyway, guys, I wanted to point that out right here at the front because I want people to understand that this is not unattainable understanding of any kind of science. Everybody that's listening to my voice right now, if you can hear me, you can understand this. Okay, and I know that some of the stuff, especially some of the other channels, they really are geared towards more of a, it's just a higher educated audience. Okay, when I say educated, I'm not calling anybody ignorant or nothing like that. It's just they have more experience and more knowledge about what's going on, right? And those kinds of channels, they tend to use bigger words, and they're not doing it on purpose, I don't think. Most of them aren't. There are some out there trying to use big words and make themselves feel a little bit smarter. But what's the point in that, right? If anybody has ever took any kind of journalism classes like when they were in high school, a lot of high schools never offered that, but mine did. I went to a big high school. And one of the first things they tell you, if you're going to write an article, write your article as if you're talking to a 6th grader. I'm not kidding. That's what they tell you. Write any information you put in the paper, they're writing that at a 6th grade level. Unless you get like the Wall Street Journal and all the stocks and this and that, I'm not talking about like financial paper. I'm talking like just a normal paper, right? That's what they teach you. So why else would we do that any different when we're doing this? You know what I mean? It doesn't make anybody stupid. It doesn't make anybody dumb. It just makes people, when you do put it out there in a 6th grade level, they're starting to understand it. And then guess what? Once they get a good base, then they can go to the other channels and really understand and dig deep. I think my role here on the internet is to really give just kind of updates and to give people a really basic understanding of what's going on. And not really what's going on, but understand what you're looking at. So you can make your own decision on what you think's happening. So, there's a lot of other great channels out there like Matthew Shipley. It's just a 24-hour live feed. He shows a lot of the, everything that I'm showing you, he'll show you in better graphics. But it runs 24/7. He doesn't really speak a whole lot on his channel. He'll break in and do a few little live streams now and again. But it's great. It's great stuff. It's 4K stuff. Fiber optics, man. I mean, he's got great graphics over there. So go check him out. Anyway, sorry about that. I just want to get that out there because I've been getting a lot of emails talking about how, I don't understand this. I'm scared of this and this and that. Don't ever be scared when you come here. Ever. If you're scared about what I'm talking about, you need to go watch something else for a while and come back. Because there's nothing here to be scared about. You need to be aware. In case something, I'm giving you the tools to understand when you should be concerned. Okay? And giving you the tools to understand cool stuff like Aurora. You know what I mean? Space weather's cool. It really is. So, anyway. So the space weather conditions for today, guys, check this out. Nothing. Absolutely nothing. Our flare level, that right there, your flare measured by X-ray. That's how they gauge them. A, B, C, M, and X flare, right? We always talk about X flare, the The scary X-flare. Well, X-flares can be. Obviously they can. It's the highest flares we can get. But, once you get to an X10, which is the top of this graph, they go way up. They go further up, guys. The Carrington event was an I can't remember exactly. I think it was an X29 or an X49, something. But it was X certain level, right? Way up there. And so if we see a flare being shown on here, and it's like up here in the R5s, guys, I mean, that's something we need to be speaking about, because with our magnetic field and stuff weakening, and it's not going to take that big gigantic, I guess it's still going to take a gigantic flare and CME to really damage our grids and stuff to where it's out for a very long time for the whole world. It would take a big, huge event, right? But it won't take as big of an event as what it used to, because our magnetic field is weakening. There's no question about it. There's just not. There's not any question about that. Used to be some questions whether or not that was true. It's no longer even a question. Nobody ever questions that, because it simply is. It's just a fact. So, but anyway, our X-ray levels are kind of like based out right here between, right at the top of a B class flare and the bottom of a C. So kind of like our standard level of X-ray right now is hanging about right there. So, and the reason why I bring that up, because the solar minimum, it's down here. Okay? So it doesn't take as much of a flare to get our X-rays into these different classes. Okay? If you're down here, you got to go further to get way up here, right? If you're here, you don't have to go as far. So it doesn't take, that's why, solar maximum and solar minimum, that's one of the reasons why they are so different. But geomagnetic activity, this is what we talk about with CMEs. Okay? We're not even hitting 2s right now. Now, again, we're in solar maximum, or we're heading towards it. Almost there. We might already be in it. I'm not going to get in that kind of a conversation right now, because, they go back and they retro and they'll tell you what they think the actual time frame when solar max was, but it will be after solar maximum is over. Okay? So just understand that. You can't tell somebody something's over until it's over, right? So that's right. Anyway, that's why I nowcast. But when we got geomagnetic activity this low, now if it, solar minimum, you'll see this thing bottom out to where none of these bars are even there. I've seen times 2, 3, 4 days with this thing sitting in the basement. Like, no geomagnetic activity. And guys, that's not good either. I know people get freaked out when you see a 9 on here or whatever, a G5 storm. Again, that's what we talk about with the bigger, huge storms. But when we get this low, we have to start talking about cosmic rays. Okay, it's exactly what that is. It's rays coming from the cosmos, not coming from our sun. It's, coming from other places. And I'm not going to get into where all that stuff can come from and all that. But we got hit like 2 years ago with the cosmic ray event. And it was the third strongest one that they had ever recorded. And they do not know where it came from. They don't know where it came from. They've been trying to figure it out for 2 years. They can't figure it out. So, that this right there tells you how fragile things are. We don't always have an answer for it. That's just a fact. So, that's why we talk about this stuff. Okay? Now, this model here, guys, I'm not going to show it to you because I showed it to you yesterday, and they have not updated it. So, it's just be a waste of time. So what I'm going to do, I'll take you over here to this is Discover. I used to show you guys the ACE data, which is essentially the same data, okay? It's just, yeah, I'm not going to get into the difference of it. But this is where we would go to see the ACE. I use this as a backup now, and most people do, okay? Because, frankly, this is way better to look at as far as a graph. So what you're looking at the top, you're looking at the BZ. That's the red line there. We look for -6 or more. That means our magnetic polarity positions our magnetic field is in a position to where magnetically Again, magnets, right? To allow stuff to come in easier. And it comes in, it filters in through the poles. Okay? So as I trickle down here, that's what that BZ is. Now the phi angle, and this is important for what I'm talking about today, the phi angle is. This is the actual polarity of the solar wind. Okay, how's the solar wind get here? It gets here on a magnetic connection line. Interplanetary magnetic connection line, right? We're all connected to the sun. If you were naked out in space, your naked butt would be connected to the sun magnetically. Okay? Every satellite out there is connected. Everything's connected to the sun magnetically. All right? So, in order for plasma, if you guys read my thumbnail and my title, plasma is the fourth state of matter, right? You got solid, liquid, gas. You got plasma. What's plasma? Plasma is charged gas. That simple. You don't need to take it any further. It's a gas that has a charge, negative or positive. Okay? So, the polarity of the solar wind matters because of that. All right? So, as it's coming here, as it's getting here on that magnetic connection line, if the polarity changes, it changes the way that it hits us. Okay? So, if we're in a positive position and the solar wind's in a negative, it's going to be sucking right in, right? And vice versa. If we're in a negative and the solar wind's in a negative, guess what? It's going to be kind of repelling it. And sometimes when this polarity flips on the phi angle here, and it does it a lot, I mean, you see it right here, that action alone, if it's done quick and hard enough, it can put us into like low-level geomagnetic storms. I've seen us get G2 storms just from a phi angle flip. Nothing else. Just the phi angle, just the polarity flipping. Okay? So what that means was we probably had some space weather hitting us, and because of our polarity, the position our BZ and everything else was in, because of that, when it flipped, it started drawing it in, letting it in. Okay? So that, and when it does it quickly, it usually does do it rather quickly. Like right here, you see where it's pink, then it goes straight to blue, way up here. That's a quick flip. And that's what it usually, you'll see that a lot on here is what I'm saying. Density. That's the density of the particles. All right? Those are normally right around 4. Now, I don't hold much stock into that because I've seen us get massive geomagnetic storms when we had a density of like 4 or 5. Okay? I've also seen us not get geomagnetic storms when the density was like 30. So, everything has to play together, right? And I say this all the time. Now, the speed is measured in kilometers per second. Rule of thumb, 400 kilometers per second is roughly 1 million miles per hour. Okay? So when you see 400 here, it's roughly. Now, you guys can go in and do the math if you want. It's not that hard. It's really pretty simple. They've even got just like simple calculators for that. You enter kilometers per second, and it'll give you miles per hour. So, lots of apps like that out there nowadays. But anyway, normal wind speed would be 300 to 500. Now, if it gets any higher than that, I've seen this again. I've seen us get 700, 800 and not really get any kind of geomagnetic storm because all the other stuff was in the wrong positioning. Now, when you start seeing, I've also seen us get geomagnetic storms when we had a wind speed of 300. So, I mean, yeah, everything matters. That's what I'm saying. You can't just look at one data point. And you'll see a lot of people out there and they'll grab it and just start hammering on it. Let's before we go any further, I want to show you this. This is ISWA. Okay? And so I'm going to show you the coronal hole. I'll zoom in here. Get a little closer for you here. We'll run the movie tool here, and Just let it run. Okay, ISPA, you guys can go there too. There's a lot, there's a lot of models on here that you guys can go play with. So if I hit play, and we'll check it out. So watch this hole as it grows, because it will. It's going to grow as it gets towards the middle here. There is a little bit of the parallax effect. Remember, things on the side of a sphere, when you're looking directly at them, if they're over here, they actually look smaller than what they really are. Okay? It's an optical thing. But this one itself is actually growing. It's clear that this one is actually growing. And it did go over equatorial region. It crossed over. So what I'm saying is it's in the northern and southern hemisphere. When we start seeing those kinds of things, that is a really strong sign that we're getting ready to see a flip in the poles of the sun. Now, it could happen in months. It could happen in a year. But it is a strong indicator. Okay? Along with, the sunspots, they're migrating towards the equator. And I've talked about it at length, and I will do so, more, but not tonight. But as you can see, guys, this is a sizable coronal hole, guys. I've seen holes very, very small give us some pretty good solar wind. When you start seeing this, again, the black you're seeing there is the surface of the sun. Surface of the sun is colder than its atmosphere. Okay? They sent, the Parker SP out there, the one that kissed the sun, right? It's still hanging around, right? They're still using the satellite. But what I'm saying is they got it into the corona, and they were trying to figure out why the corona of the sun is hotter than the surface. What is causing that? And they got some really good theories. I highly encourage you guys to go check that out. Simple Google searches will get you a good start. Okay? But as far as this model goes, the colder the temperature is on this model, the darker the color is. So the black is actually the surface because it's the coldest thing around. And in contrast to that, you see the lighter colors, and what do you see there? That's the corona. That's the corona, right? The atmosphere of the sun. And that, the black back here, guys, that's cold too. That's the darkness of space. So anyway, that's the 211. Again, what's the 211? I get a lot of questions on that. That's the angstrom of light. We don't see very much of the light spectrum. Okay? Our eyes do not see a whole lot of the light spectrum. Okay? Now, as I said earlier, you see where the sunspots are? They're getting really close to the equator, right? You're not seeing them down here anymore. We'll get one every once in a while down here. But they're migrating towards each other. Another very strong indicator of, we're getting into solar max, and when that magnetic polarity flip happens, things reset. Okay? What causes a sunspot? And I'm going to give you just a little quick whatever on that. And actually, I think I will, let's take it to, probably what the best one to show you on would be probably the 171. That seems to be, we'll let that load. As that loads, we'll look at something different. Okay. This is GOES. Okay, this is GOES 18, I think. I'll back out a little bit. Nope, GOES 16. Okay. It's another satellite. They're basically in the same position. Okay. Again, this over here is SDO. It's the one that's in geosynchronistic orbit. Stays over the same part of our planet and rotates at 15 degrees an hour around our axis, just like we do. Okay, this is why you see things in the sky kind of move the way that they do. Because if you're up here, you're not moving as far, are you? But you're still moving at 15 degrees an hour. You're still moving at 15 degrees an hour if you're down here on the equator. Because this is two-dimensional right here, right? But the sun itself and us, we are all on a three-dimensional sphere. And we're looking, they're trying to represent this two-dimensionally. So as you go down latitude-wise, you got to understand that the distance you're traveling is further than when you are up here. So we talk about it when we're talking about the rotation of the Earth, we talk about it in terms of degrees, because you're actually moving faster if you're down here. You're covering a greater distance, okay, to move the same 15 degrees. You guys understand that? I hope you guys understand that. Hope I didn't, confuse people there. So what I'm saying is, if this is the axis, if you're standing right on that axis, you're not moving very far when you're spinning, right? But if you come down here, you definitely are. I mean, you're moving a lot, okay? So that's what I'm trying to say there. And I know most of you understand that, but if you don't, hopefully I helped there a little bit. Okay, so here's all the sunspots. We can see them really well on the 171. You see all these little bright spots. Those are little cores. Here's a big one over here. But you see how this is the equator, right? See how they're getting closer and closer? Now, if I was to take this back 2 or 3 years, you would see sunspots down here. That's just what you would see. So when the poles flip, right, what happens is the magnetic polarity lines of the sun, you got positive and negative, right? Okay? It's vertical. Those connection lines are vertical. So the equator of the sun actually rotates faster in degree. Okay, not just speed. I'm talking degrees. The equator, equatorial regions of the sun rotates faster than what the poles do, the polar regions. Okay? So what's happening is you got a vertical line like this, right? Well, as it progresses, those magnetic lines start to get pulled like this. Okay? It's kind of starting to bend like that. And then as we start to get further and further, they almost become horizontal. Okay? See what I'm saying there, guys? So you got positive, negative connected to each other. And because the equator of the sun, equatorial regions, actually rotates quicker, is moving faster than the poles. And the reason it can do that is because the sun is not a rock. Okay? It's a big old ball of plasma. So, I mean, anyway, that's why it can do that. So as it's pulling that way, it starts to pull those magnetic lines. So what happens is kinks in those lines poke through the surface, and that's your sunspot. Okay? That's a very basic way to understand what a sunspot is, how it's formed, and what it does. They start off, very, very, very much in the polar regions, and as we go further on into the sun cycle, they start to migrate towards equatorial regions. So that's what happens there, guys. And, it does it slowly, okay? So you get like a little soft little bend there in the middle, right? Well, as time goes on, it starts really doing one of them numbers, right? So it just pulls everything in. And then when you get kinks in those lines, sunspots poke through the surface, and there you go. Now I have to give a shout out to Tamantha Scove for that explanation, because that's exactly how she explained it on her channel, and I thought it was the best one that I had heard for understanding it. I didn't completely understand it until I heard her say it. So if you guys don't know who Tamantha Scove is, go over and check out her channel. They call her a space weather woman. She's a professor. She's a physicist. I mean, guys, go check her out. That's all I'm going to say. And she doesn't try to talk over your head either. So just know that. She's been on the Weather Channel and all kinds of channels talking about space weather. So, I mean, she knows what she's talking about. And she does it in a way, she even will actually bring out a slinky to explain magnetics and how our magnetosphere is around our planet. It's pretty cool. I mean, that's the kind of stuff I'm talking about. That's how it needs to be explained to the general public and to most people that aren't just general public. You'll get a very good understanding when you start doing stuff like that. I hope you guys agree with that. But anyway, hey, Trinity, good to see you. Guys, go check out Trinity. I popped on here earlier, right before I did my live stream here, and she had done a live stream. I didn't know she was streaming. I just now was able to sit down and do what I needed to do for this. So I'm just now looking at the internet. Anyway, go check her out, guys. Drop your link in there, Trinity. Okay, so what we're going to do here is I'll show you the seed site here. And this is the most up-to-date data, okay? This is what happened today. You're going to see a couple eruptions here. This is an occulter disk, right? That's a black disk on the imager itself. It's a physical disk. It has to be there to block out the main light of the sun. If that's not there, we get no imaging at all. But it would just get overexposed with light, okay? So you can kind of see over here, I'm not sure, can't really see it on this one, but like on stereo A, you'll actually see a arm holding this thing. It's like a darkened area, but that's what that is. So, and remember, this right here, this little circle here, that's trying to represent the surface of the sun. Okay, so this occulter disk is not the surface. So when I talk about a halo eruption like that one right there was, that means it's either going directly away from us or it's coming right at us, because we can't see the eruption itself in the middle, right? So but if you see in the energy, pretty much the same diameter coming out, poking out around this occulter disk, it's either going the opposite direction or it's coming right at us. So when we see things like you just seen right there, don't worry about that flash. That's just a camera anomaly. Okay. So as I go forward here, I'll show you the halo. So there's an eruption, right? There's your halo. All the way around. So the next question is, we've seen that, right? We see a halo eruption. Is it coming at us? That's the very next question you need to ask. So, best place to go check that out most of the time is the NASA Enlil spiral, and that's what we're looking at right here. It's the same one I show you over on NOAA. This one. Okay? But they use the same data, but they take the data in consideration differently. So they get different forecasting. Okay, the models are different, is what I'm saying. Now, when they agree with each other, it's just like a hurricane model here on our planet, guys. We've all seen the spaghetti line models when a hurricane's coming in. How many of them are there? A bunch, right? Do they ever agree, especially when they're like a week away? No, they never do until they get like a day before they get here. And we got to keep that in mind. That's what's happening there. So, what you're looking at here is a top-down version on the left of our inner solar system. You got the sun, you got the earth right here. This is a side cut, and this is our orbital line stretched out in a straight line. So, we want to know if that CME, that halo we just seen, is coming at us or going away from us. Well, this was going away from us. And let me show you. I'm going to zoom in here. This one's kind of hard to see, but you'll see see that right there? That was that halo eruption. Okay? So this one's actually going the opposite direction. That's not going to hit us. Okay? Now, I'm not sure exactly the strength of that, because when they're flying off the backside, we don't have as many detectors back there as we do on the front here, between us and the sun. So, it's hard to get a good, accurate what's going on as far as how powerful something is. Alright? Now, I wish Stereo A was still out there about 90 degrees. It used to hang out over here, but it's here right now. It's hanging out by Earth. And I think they're trying to do some updates on its software and stuff, and they're going to try to send it back out. It's already lived past its life expectancy. But, hopefully they send it back out. We'll get some more views from, the side so we can see the backside of the sun a little better. But they have got new technology now called seismicity, or I guess that would be the word for it. helioseismology, they use that to map out the back of the sun. They're using seismic activity on the sun to tell us what the backside looks like. And they're getting really, really good at it. So, it's really cool. But anyway, this is spaceweather.com. Let's talk about this for a minute. The Geomagnetic Storm Watch has officially been canceled. It was expected to graze us today. Hasn't arrived. So either it missed us or it's moving more slow. Either one is going to make it weaker. Okay? So unless this thing hits and it's more dense or something than what they had expected, even though it's moving slower, a higher dense hit could actually put us in the storm level. In other words, we're not going to see much of anything from that. So the geomagnetic storm I was talking about yesterday, the watch, I don't know that I would put too much stock in that right now. I wouldn't be like saying, hey, pay attention to this, that, and the other. I'm not saying it can't happen, but yeah. Now, I want to talk about this real quick too. Widespread polar stratospheric clouds. This is kind of a big deal. And the reason why is because we're seeing them in a lot of places. Like outbreaks of them, outbursts. Okay? They look a lot like aurora, but they're actually clouds. So what I'm going to do is I'm just going to read this real quick. Okay? So December 17th to the 24th, temperatures in the Arctic stratosphere dipped to a 40-year low. Think about that. The coldest it's been in 40 years. I've been on this planet 48 years. So the last time that they seen this, I was 8. Anyway, the result was a widespread outburst of polar stratospheric clouds, PSC. Okay, they usually hang out in the Arctic Circle because obviously things are colder there. Well, he even said, Dr. Tony Phillips here says aurora-like clouds descend all the way to Italy and the south of France. Look at this, guys. Look how far south they went. That is amazing to me. And it wasn't just a few. I mean, these are the sightings. Okay? So what that means is the stratosphere was really cold. And I'm not going to get into exactly what causes the PSCs, polar stratospheric clouds is what they call them. But they do look like, let's do this. He's got a hyperlink there. That's what they look like, okay? Whose image is that? Let me give him credit. Guys, photographer's website, go check them out, guys, please. Go give them some love over there. If one of my mods could grab that link and put it in the chat, I would really appreciate it. These guys work hard to get these photographs, guys. So please give them some love. They really do. Especially stuff like this, because this is not normal. This is not a normal thing to see all the time. So it's rare. So please go check them out. Let's see here. I want to see. It says that, well, the photo's over at flickr.com. Quite amazing. Trying to see if there's a name. Okay, here we go. Alan C. Tuff. That was Christmas Eve. Elgin Moray, Scotland. So, guys, go give them some love. Click on this. Show them, hey, we appreciate what's going on. So, I would really appreciate that, guys. Please. But anyway, that's a PSC, polar stratospheric cloud, and they happen when it gets cold. Very, very cold in the stratosphere. They're very high up clouds, too. Okay? Now, you notice I haven't been talking a whole lot about noctilucent clouds. And that's because, well, I'm not going to get into why. The stuff we were using to look at that stuff is not working. The satellite, it just is not working. Right here. So we got a different model now. I used to show it to you. It used to be like a blue thing here. It'd show around the poles. And it's a good indication of what a noctilucent cloud is. It is ice that freezes around meteor dust. And it gives us a very blue metallic looking like cloud. So when we start seeing, again, it has to be cold for that, right? But the surface has to be kind of warm. You have to have moisture, right? So when you start seeing them getting towards, coming down in the mid-latitudes, out of the Arctic and Antarctic circle, basically being closer to the equator, closer than they really should be, normally. Now, it's very normal to see the rare things once in a while. But when you start seeing them, the rare things become a normality, that's when we got to start looking at things. And noctilucent clouds, from what I've been seeing for the past few years, definitely have migrated north and south, closer to the equator, than what we would have considered, 10 years ago. So, that's just another, thing we need to pay attention to. So, anyway. All right. So, what's all this mean? Well, it means that we got a coronal hole that is going to be the main driver of our weather right now, space weather. It does mean that we could see geomagnetic activity and geomagnetic storms once we connect to this thing. Okay? Now, that stereo A here, that's the one that used to be out 90 degrees, and it's giving us the same view as SEEDS did. Okay? So, for the next few days, guys, we do have this one incoming. It says it's missed, right? But if you scroll up, right here, like right now, well, about 2 hours ago, it says we should be at about a 4 on the KP. Okay? And that would be almost, this is a 4 right here. That would be almost a G1 storm. So, guys, I don't know what else to say there. Again, that's why I nowcast. Either way, it's not going to be a big deal, but if it does end up being bigger, now I do think we're going to start seeing some more eruptions, okay? Because we are definitely seeing more activity going on, all right? So this is what's happened today. This is Soho. It's 1 million miles closer to the sun than what we are. Always looking at the sun, and it orbits around the sun with us. So it takes it roughly 365 days to orbit also. But it's always looking at the sun, but it gives us our point of view. This thing catches sun divers like nobody's business. And again, I guess I could go to the previous day and show you that real quick. But yeah, these sun divers are something else. Okay? Let me go here to the previous day. I think this is when no, it wasn't. Hold on 1 second, guys. Sorry. All right, let's go here. So, there you go. That's on the 24th. You're going to see the sun diver dive in, and I did a 1-minute video on this. There's your sun diver. And then shortly thereafter, we started seeing eruptions on the sun. Now, again, I don't think this sun diver caused all 4 of those eruptions. What I think happened was it destabilized it enough that the first one happened. And then once that big one happened, that's what started the chain reaction. Okay, that's my opinion. And we could, I showed you guys this yesterday. But we're not going to rehash that. But it definitely is... I think that's my opinion on what actually happened there. But those are large eruptions, and those are the ones that they thought might be hitting us. But there's your sun diver right there. I'll back it up so you guys can see it better. Okay? It's pretty photogenic. Sometimes we'll see these, and it'll be a little dot just racing across the screen. But yeah. Okay, so look at that. Update that. This is the German website, guys. It's another way to see the KP or the HP. Look at this. No geomagnetic activity for like 3 hours. So that's what I'm trying to say, guys. I mean, we got to pay attention to cosmic rays, and that's kind of what I'm saying right now. Now, once the solar wind stream gets here from that coronal hole, that's going to change. The geomagnetism will actually help block out some of those cosmic rays. So we have to have that balance, and I talk about that a lot. So, but anyway, guys, I am going to go ahead and take off. Guys, go over and check out Marfugal. He's going live. He's probably live right now. I know he went live on Marfugal News, but he's going to be going live on Marfugal TV. Also, I'll be there, guys. I'll be in the chat. So if you guys want to come hang out, that would be awesome. Go check out Tommy and over on the Lifeboat, Mark Pyers, Trinity, Ripper. Everybody I always talk about. Johnny over at Chase the Heat. Great people, guys. You guys just want to have fun and watch somebody eat some really hot peppers. He's the GOAT, man. Greatest of all time eating that stuff. Man, I can't imagine some of the stuff he's eating. It would have killed me. Anyway, and they're all great people. So, just so you know. Anyway, guys, I am going to pop off. And God bless. And come back tomorrow. I'll be here. All right? Yahusha saves. Thanks for trusting me and getting here, guys. I'm going to try to do this every night. God bless. Yahusha saves. And you can drink this Kool-Aid.